sa inyo. Okay, so tonight I'll discuss how GIS is helping to build resilient communities by mapping vulnerabilities and risks through the climate and disaster risk assessment. Okay, so data show that there is an average of 20 typhoons in the Philippines every year, and some have been very destructive, severely damaging properties, and costing a lot of lives. So this calls for the need for the Philippines to address the disastrous impacts of these hazards. And with that, one tool that we use is the climate and disaster risk assessment. So the climate and disaster risk assessment introduces a systematic approach in better understanding impacts of climate change and disaster. So it identifies vulnerabilities and risks of every unit that may be exposed to hazards by analyzing their exposure, their sensitivity, or the degree into which they will be adversely affected, either negatively or positively by climate impacts, and their adaptive capacities, or how they will be able to prepare, respond, and recover to disasters and climate change. So we have two laws, and in response to the global efforts for addressing climate change and disasters, the Philippines has formulated two laws. One is the Climate Change Act of 2009, or RA number 9729, and we also have the PDRRM Act of 2010. So both of these aim to strengthen CCA and DRR in the Philippines, and they focus on policy formulation, budgeting, identification of programs, projects, and activities to address the impacts of climate change and disasters. And we also have the General Appropriations Act of 2018, which mandates the UP Resilience Institute to empower LGUs with science-based information and to equip them with the proper knowledge regarding climate change and disasters. And through the CDRA, the UP Resilience Institute with the NOAA Center can help them with their local planning and with the use of multi-scenario probabilistic hazard models. So we stress the importance of probabilistic hazard models. When we say probabilistic, we don't focus only on a single scenario into the extent that the community only knows of, but we consider the representative concentration pathways, or the trajectories of greenhouse gas emissions in the future years. Okay. So, the previous presenters have mentioned a while ago about the representative concentration pathways, and we have to consider the climate projections. That's why we really need probabilistic hazard mapping. Okay, so the CDRA has 6 steps, and in the UP Resilience Institute and NOAA Center, we make sure that the community is very much involved in these processes. So we want to be more inclusive, and we promote participatory planning because we can better gather information if we include the community in the whole planning process itself. So in these steps, we conduct workshops and we facilitate activities with them to gather information. We validate the data that we get from them. So we do interviews, we do plenary discussions, and among other activities. So we collect and organize climate change and hazard information. So from this photo, we can extract a lot of hazard information from it, the extent, the damage, and the factors that contributed to the damage. And the next is scoping potential impacts of hazards and climate change. So we do this by doing a climate impact chain analysis, wherein we identify a climate stimulus in a locality, and then we identify the resulting hazards and its potential impacts. Okay, so next. So these are just photos of how we conduct these steps, and actually the one photo here is from Naga City, Cebu. So the UP Resilience Institute is currently assisting the LGU for their local development planning. So after these steps, we can now develop the exposure database, which details the exposure, sensitivity, and adaptive capacities of a community, of every exposure unit in a community, as I've mentioned earlier. So we have 5 exposure units, and they focus on the population, the urban use areas, our commercial areas, our industrial areas, our farms, and any urban land use. We also have our agricultural areas or our natural resource-based production areas, and we also have our critical point facilities which provide basic social services for the community. And lastly are the lifeline utilities, our road networks, our communication lines, power lines, and water lines. Okay, so just some photos. So we validate these and work with the LGU and the community for us to be able to understand better the research. So we don't do this in research alone. We work with them so that we can be able to do a successful climate and disaster risk assessment. So after this is where the GIS part comes in. So we map the exposure units from population to lifeline utility. So having the satellite image of a certain community, we can now map the exposure units. So for example, the population areas. Then in red, we have the urban use areas. Then next are the agricultural areas, our critical point facilities in blue, and our lifeline utilities. So from there, we can now start assessing their vulnerabilities and risks to hazards. Okay, so just some photos again. After mapping all of these, making sure that these are validated with the community, we can now assess their exposure, their sensitivity, and adaptive capacity and proceed to the next step. So the next step is conducting a climate change vulnerability assessment. So this is more focused with the vulnerability to hazard or the susceptibility of a community or if they are unable to cope with climate change and hazards. So I'll just show you the formula for it. So we add exposure to the sensitivity to get the degree of impact and multiply it by the adaptive capacity, and then we'll be able to get the vulnerability. So next, we have the disaster risk, and its difference from vulnerability is when we talk about risk, we talk about the potential losses or the damage, or potential loss of lives, potential damage to property. So we have exposure, sensitivity, then the magnitude of the hazard, and we add them together to get the severity of consequence, and then we multiply it to the likelihood of occurrence or the probability that a hazard is likely to occur again. So that's how we calculate risk. And using the map that we generated from the exposure unit, from the exposure database, so for example, this map, our exposure unit, so it's comprised of the 5 exposure units, and overlaying the hazard assessment done by the UPRI Center. Actually, my presentation is very much related to the other presenters. So they presented how landslide and flood are modeled, and we use that assessment in the UPRI Center and our research to get the vulnerability and risks of communities. So the map on your left is the vulnerability to flood hazard. So you can see that the hazard is overlaid with the exposure unit, so you'll be able to know where the low, moderate, high vulnerability and risk areas are. Okay, so that's how GIS is used in the climate and disasters assessment. So after steps 4 and 5, we can now proceed to step 6, which is summarizing the findings. So what do we do with that information? So this is very important for the communities. So we now know that these areas are affected, will likely be affected by certain hazards and climate change. So the step 6 is we have to summarize our findings so that we can plan better. And we have 4 steps in that 6th step. If you imagine, so we identify the decision areas. We are now able to identify where the low, moderate, and high areas of hazard are. And then we identify the implications. When we say implications, these are the effects, the negative effects if these hazards are not addressed, if no measures were undertaken to address these impacts. And next we can now develop risk-sensitive policy interventions or policies, programs, and projects that we can make use to address our implications. So after this, with the LGU has limited resources, manpower, and we have to take into consideration the planning period itself. So we have to prioritize the projects, what we really need right now. So that's step 4. And then we can now mainstream the results of the climate and disaster risk to the local plans, our comprehensive land use plan, our comprehensive development plan, and all the local plans that the LGU needs to be able to provide better decision making towards climate change and disasters. So I'll just show you some examples that we do in the UP NOAA Center with the help of CEDRA. We are helping LGUs to formulate all of this. So we have their existing land use plan. So for example, we have the municipality of Padre Garcia, Batangas. So you can see their existing land use, and when we overlay it with the hazard, you can now see the low, moderate, and high areas of flooding. And that will guide them in having a proposed land use wherein climate change and disasters are taken into consideration. So maybe you can see all the difference, but this is a proposed land use, so they wanted to add a commercial strip along the highways, and referring to the map where flood hazard is low, they can see that they can develop in these areas. So that's how climate and disaster risk assessment is helping communities through GIS. Okay, so with that, with all these information, LGUs can be equipped with knowledge on what projects can they implement. So for example, they can implement some resilient socialized housing projects for relocation when some settlements have been seen to be in hazard-prone areas. Then they can also maintain and reconstruct or construct more infrastructure to address climate change impacts. So, for example, we have slope protection projects, maintenance of drainage canals, and construction of other infrastructure. So that's basically how CEDRA helps LGUs. Okay, so just to wrap up my presentation, earlier it was mentioned that disaster risk is an unresolved problem of development, and it is very important for LGUs to be and communities to be able to see climate change, to be able to know climate change and disasters and what their potential impacts may be. And when the sooner that they know about all of this, the sooner that they may be able to plan and mitigate for it. So the goal of CEDRA is to reduce the vulnerabilities and risks of the communities to hazards, and we want to increase their adaptive capacities for whatever disaster may come. So the sooner they know, the sooner they will be able to mitigate, and the better we plan, the less risk that we are in. So that's all for my presentation. Thank you.